Good morning, algebra students, and welcome to the second part of 3-8. So today we are going to be at the very last page of our packet at the end and start on problem 3. So we're going to focus today on using Venn diagrams and showing elements of sets and then writing them with inequalities. So a Venn diagram, remember, is when it has like a circle and then another circle and they overlap in some way. And sometimes there's more than just two. So problem 3 starts with this. It says, 3 friends are going camping. The items in each of their backpacks form a set. Which items do all 3 friends have in common? And so what they want us to do is make a Venn diagram to show this. So let's start off with just realizing that, like, if we make a Venn diagram, we have a universal set around it. So the universal set, let's make a big rectangle here. The universal set would be like everything in the store or everything at their houses or something like that. So the Venn diagram now is going to overlap 3 backpacks, okay? So we have 1, 2 overlapping, and then to overlap a third, you kind of do it like, I think the Olympic rings are like this, okay? And you have a third one. And let's just label this. This is backpack A, this is backpack B, and this is backpack C. All right, so we'll label each of these. This will be backpack A, B, and C. And it's a little hard to see on here, but what we want to do is we want to see what do each of these backpacks have in them and what do they have in common, okay? So for backpack, for what all 3 of them have in common, if you take a look at them, right, it's a little bit difficult to see on a copy here, but it appears that there is a hat right here. See it? This is a hat. There's a hat in this one right here. Same thing. And there's a hat right here as well. Okay, so we would list that in the middle. And I'm just going to write an H because it's kind of small. So they have a hat in each of them. It also looks like there is maybe a map or a guide in each of them. There's one right here. See it? And then there's one here. And one right here. So I'm going to call that a map. That's in all 3 of them. And I see one more thing that's in all 3 of them, and it looks like there is a water bottle in all 3 of them. If you look, here's a water bottle here, a water bottle in this guy, and a water bottle here. So I'm just listing those with the initials because, well, I can't fit them in there. So that would be what are listed in all 3. Now, are there any in there that you can see that 2 of the backpacks have, but maybe not all 3 of them? So if you take a look, right, it appears that there's a first aid kit in backpack B, and there's also a first aid kit in backpack C. So you would list that where B intersects C. So I'm just going to call that first aid like that. And let's see, is there anything else that it appears is in 2 of the backpacks and not the other? Oh, there's a pan, it looks like. So there's a pan right here. See it? And then there's another pan in this backpack as well. So we'll list the pan in here. That's A with C. And then anything that are in the backpacks that are not in the others, you would list in the circle itself. So like in backpack A, you can see there's sunglasses in there, which are not in any of the other ones. What else is in there that we don't see in any of the other ones? Oh, right here, it's hard to see, but this is a flashlight. That's not in any of the other ones as well. Okay, how about in the middle backpack there? Is there anything in here that you don't see? Yes, there's a camera right here. So that's in backpack B, but not in any of the other ones. And then in backpack C, the only thing I see in backpack C that's not in the others is this rope right here. All right. And so this is how you would create a Venn diagram with just to show what things have in common, just like that. So the universal set, again, is all their camping gear maybe. And then A, B, and C represent each of the backpacks. and where they cross over and which ones they have in common. Okay, next one is now a little bit more mathematical, all right? And so this was like a qualitative situation. This is a quantitative situation where we're going to need to do some numbers and do some math here. So it says, of 500 commuters polled, some drive to work, some take public transportation, and some do both. 200 commuters drive to work and 125 use both types of transportation. How many commuters use public transportation? So what they want us to do here is use a Venn diagram to show this. So we'll do it again. We've got our universal set here. Whoop. That's going to be all the types of transportation, but specifically we're talking about driving to work and public transportation. So here's driving, here's public. Okay. And then what we're going to do is we're going to use the numbers that we know here. Okay. So it says 200 commuters drive to work. Okay. So this total right here is going to be 200 for the total. All right. So 200 drive to work total. That is going to include those that just drive to work and those that do both the types of transportation. 125 goes in the middle here, right? So if 200 drive to work and 125 do both, right? Then that means that there's 75 left over that just drive to work. The question is, how many commuters just do the public transportation? Okay. And so this is how we do this, right? So 200 that drive to work plus the 125 that do both is 325 transporters, right? And it tells us in the beginning that 500 was the total polled. So if we take that 500 and we subtract our 325, then we get 175 left over that do the public transportation. Oh, sorry, I should have labeled that 200 in here, shouldn't I have? Oops. Okay, and that's how we do it. All right, last but not least, this is one that you'll see more of. We usually write inequalities the way we've been writing them, but once in a while, they're asked to write them as unions or intersections of sets, okay? So the rules for this are that and, if we get an and, it's going to be an intersection. And if we get an or, it's going to be a union. Okay, and so what we're going to do is it says, what are the solutions of the absolute value of 2x minus 1 is less than 3? Write those solutions as either a union or an intersection of two sets. So first thing you have to do is you have to solve it and graph it to see if it's an and or an or. So remember, to solve this, what we're going to do is we're going to do 2x minus 1 is less than 3 as is, and the other one we're going to solve is 2x minus 1 is greater than negative 3. Okay, so let's solve them. We're going to start by adding 1 to each side. So 2x is less than 4. On this side, it would be 2x is greater than negative 2 then. And then we're going to divide each of them by 2. And so we get x is less than 2 here. And then on this side, we get x is greater than negative 1. So the question is that an and or an or, first of all? So to be able to do that, we're going to graph it out. All right, we know our low limit is negative 1, so let's make sure we've got that. And our high limit is 2. All right, these will be open circles. And okay, so the 2 is going to be pointing to the right, and the negative 1 is going to be pointing to the left. So they are going to connect. So this is an and question, right? So this is how we write it then. And is going to be an intersection. The way we would write our answer is this. The set x is greater than negative 1. That's our first answer, right? It's really our second on here, but I want to go in order. That's the low answer. Intersects, because it's an and then we write this set. X is less than 2. And that's how we would write it as a union or an intersection. If it was a union, it would be pointing outward, right? And we would write each of them, and we would write the U in the middle. Intersection is the upside down U. Okay, hopefully you found that helpful. The assignment today is to finish the back side of 3-8 practice. If you have any questions or need help, please feel free to email me. Have a great day, everybody.